Hello everyone, I'm Sneha Sahiti Bamati and I'm pursuing my master's in the stream of data science at University of North Texas. This is my reading assignment 7, the subject knowledge, data analysis and knowledge discovery. I have read a paper named Sport Risk Analysis based on knowledge discovery and data driven, and it was written by Jingling Jin and Chuan Fan. And here is the summary of that paper. We all know that sports have gradually gained popularity and the risks associated with them have risen as well. In today's world, college students are a diverse population and sports are very popular among them. The construction of sport risk assessment system in ordinary colleges is significant to improve physical quality of college students and ensure safety. College sports accidents have occurred on occasions in recent years, causing not only enormous pain to students and parents but also casting a dark shadow over the sport. This work takes the risk analysis of college students' sports as the background and uses a data-driven neural network to conduct knowledge discovery of college sports trends. It evaluates the sport risk of college students' physical education and builds an index system of sports risk and assessment in ordinary colleges and universities, which provides a certain basis for avoiding and reducing sport risks. This work studies an end-to-end one-dimensional convolutional neural network algorithm for risk assessment of college sports. In order to extract complementary structures in different scales, a multi-scale fusion framework is constructed using convolutional kernels of diverse sizes. So in this paper, the author have explained the residual network structure is introduced to deepen and improve the networks. And an attention module suitable for one-dimensional residual network is designed. It is embedded into the residual module to construct a multi-scale attention residual network MSAR model. Finally, validity and superiority of proposed model are verified by experimental data, which can effectively evaluate the sports risk of college students. Cognits were employed to carry out an edge automated and cognitively risk assessment that address the drawbacks of traditional sports hazard assessment methodologies such as convoluted methods, reliance upon domain experts, and poor sign preparedness. The crossing yet again another neural network deep framework described in this research is further enhanced with a mathematical formalism and residual mechanism. To meet the need for university students from society, it is essential to produce graduate students who really are varied in all aspects of development, including intellectually, morally, and socially. Today's academicians primarily build testing systems from the perspective of a specific league's risk in inter-college athletics. But they rarely try to build a whole gym classes worth of instructor risk evaluation indicators. Work gathers a range of danger information relevant to students' athletics on its own, which is used to hone the technology and evaluate its performance. The set consists of 35,030 new tests, of which sample instances make up half. Each group is defined by 12 university athletic related risk variables. As previously stated, this work uses learning algorithm on a variety of scales to segment the data using segmentation method. As was already noted, the MSAR method in this research employs recurrent neural systems that are based on SE and CBA. This study conducts appropriate methodology to evaluate the tracker system even without the long short attention span to show the effectiveness of this approach. The CNN model example sites end up sampling of CNN process its data objects. As the number of channels combined increases, the dataset size shrinks. Additionally, different hidden layers widths yield different extracted features. In order to facilitate feature learning, the network's deconvolutional layer frequently execute patching and redistribution. The extracted feature is then used to redistribute the obtained picture data to following layers, which are coupled with the softmax activation stack to determine the recognition rate. The control and helps elements that make up CBAM are roots and resigns similar to the SE modules. The provided subset of features must be compressed before channels association can be used to calculate circuit attention. In order to enhance circuit recognition, average sharing and convolutional are used to merge the location data of the subspace. The maximum and median aggregated characteristics of the characteristic indicate respectively. Concatenating these binary images maps and then putting them through a convolutional coordinate produces the set of cognitive photogrammetry that provides the position information of reinforced or inhibition. So the critical analysis that I have wrote here is, in my opinion, reading written material or information is both difficult and manageable, and it's generally excellent. I'm rather intrigued by learning about data set knowledge discovery methods, and the elaboration is excellent to use this paper for the reference because I'm fresh to this kind of topic. The principles of knowledge discovery, and in particular the safety of the communication aspects of the process that go on, were well explained by the author. The idea that future technology may be more detailed and highly predictable is how I came to learn the aim of this paper. Yes, I was able to understand the research strategy of the author used to achieve the best outcomes. The layout is identical for the study topic because modern network technologies are crucial for producing better outcomes with the historical data that we have obtained. I'd like to get more detailed information on how the existing standards approaches operate. The author put a lot of effort into gathering data and outlining each network strategy, which paid well. Additionally, he made several crucial recommendations that included more precise details about all the studies they have employed. The themes that were mentioned regarding data gathering and data network approaches should be further elaborated, and there should be some publications with more thorough explanations of ease of understanding. I get a lot of fresh knowledge from this documentation. Convolutional neural network, multi-scale, and network laws are the key things I have learned. As according to prior studies, the methodology recommended in this study can enhance the capacity to evaluate activity risk. Naturally, the strongest evaluations result from the emphasis of SE and CVA. The questions that have rose in my mind is how this can be used in real world scenarios. And the other question is which explanations of the excitation operation and squeeze operation is preferable. And these are all the references that I have taken from. So this is the end of my paper summary, critical analysis and questions. Thank you. Thank you so much for listening.